hello to everybody today. I'm here to talk about some of the challenges and solutions that we see from a grid perspective in integrating offshore wind. And it's very encouraging to see the attendance here today and the interest in offshore wind. We definitely think in Eirgrid that offshore wind has a massive role to play in the future decarbonisation of the Irish electricity grid, and we feel that it's our role to be facilitators where possible for offshore wind and for every other technology that can help us meet that goal. So I'm going to talk about some of these questions, and I'm going to try and give some answers to the questions. I probably don't have all the answers. In fact, I know I definitely don't, but I'm going to give it a shot. And I'm going to focus on two main areas. One is the network side of things, which is where a lot of the attention seems to be at the moment. Where do I get grid access? Once I get grid access, can the network actually manage the power flows that would then come from the offshore wind generation? And then on the other side of things, I'm going to touch on the operational perspective, which is where I'm mainly focused, and a lot of my current work is in relation to the DS3 program in Eirgrid. So can the system operate with a larger single infeed? A lot of people don't realise, but the largest connection that we have on the Ireland and Northern Ireland power system at the moment is two 500 megawatt interconnectors. So a lot of offshore projects are much larger than this, but a lot of our systems have been set up to deal with 500 megawatts as the maximum infeed. So how do we change that, and what do we need to adapt in order to be able to increase that level? Then the other question is, if we connect 20 gigawatts of offshore wind generation to steal David's number, what are curtailment levels likely to be, and how are we actually going to manage that energy on the grid without turning down the wind when we run into stability challenges? So to begin answering those questions, I'm going to start with a bit of the energy landscape, and a lot of people have already touched on this, so I'm not going to spend an enormous amount of time. But prior to the ECP1 or Enduring Connection Process timeframe, we had 5.6 gigawatts of applications to connect onto the Irish system, most of which were on the east coast, a lot to do with the favourable depths and the distances to grid connection points. I've tried to group three of the main areas here, running from essentially Louth all the way down to Arklow, and the levels of interest that we're seeing in these areas. When ECP1 was run, one of the Warden's criteria was for planning permission. And planning permission for an offshore wind farm is very difficult to quantify. Some have foreshore leases, is that planning consent, and some have consenting, is that qualifying as planning permission. And what we see, and talking a lot to our connections and contracts department, is that this is the area that really needs the work now in order to progress, and in order for us to enable the quick connection of offshore wind over the next 5 to 10 years. So we would see the overhaul of the foreshore consenting process to be essential to this, and to be able to obtain licenses and then to modify licenses accordingly. The other thing that we need to think of when we're thinking about how can we facilitate offshore wind is the timelines associated with that. So when do we need the network to be there, or when do we need to be able to operate the system at that time? We believe that a lot of this is going to be to do with the successful outcomes of the upcoming RES auction. So just at the bottom there, you'll see the timeline of the next 10 years, with some of the gold stars highlighting some of the RES auction timelines. RES 2 in 2020, RES 3 in 2021, which is likely to be the first time that an offshore project could qualify for RES auction. And then if you take into account the timelines for financing and then for construction following that, you're really talking about 4 or 5 years after the outcome is known from the auction to when you might actually see some of these materialising on the grid. So it's really towards the latter end of the 2020s that we see offshore really taking off in Ireland and in Northern Ireland also. And then we have to consider the sizing of these. Typically 700 to 800 megawatts are the sizes in smaller jurisdictions like ourselves. So how do we manage this potential 3 gigawatts of offshore connections by 2020 on the grid, when a lot of it is arriving towards the tail end of the decade? And you'll see there that I make reference to one of Eirgrid's Tomorrow's Energy scenarios. So you might be asking yourself, what is that? So Tomorrow's Energy scenarios was taking a scenario planning concept, looking at different possibilities of how the electricity industry might develop over the next 10, 20 years, and then using that as a tool so that we can be able to plan the network more efficiently and be able to operate the system more efficiently in the future. So Tomorrow's Energy Scenarios 2017 was published last July. July 2017, I should say. It sets out 4 different types of scenarios for Ireland's future, going from a slow change where the economy is not doing great and there's not an enormous amount of change on the grid, to a low carbon living where there's widespread economic growth. There's a lot of new interconnection, a lot of new offshore grid, and a lot of data centres. And all of this provides a lot of challenges for integrating this onto the grid. Our publication is going to be revised every 2 years, so we're expecting another one in summer 2019. We're going to be opening a consultation process for that in Q1 next year, so please do give us your input and your feedback into that. And maybe just to pull out some of the numbers that we saw for offshore wind in the TES 2017. What you'll see here is we're going from our existing capacity of 25 megawatts, which you can see out the window, to potentially 3 gigawatts of offshore wind generation by 2030. The range that you see there is quite wide, going from 250 megawatts in slow change to 3 gigawatts in low carbon living. And I think that really reflects the uncertainty that was in the industry at the time when the scenarios were developed. A lot has happened since then that has given us more certainty as to what will happen in the next decade. And I think if I was doing the scenarios again today, I'd probably have the upper echelon a little higher and certainly increase the lower boundary also. So the next step in our scenario planning and our planning for our energy future timeline is to take these scenarios and then overlay them on top of the existing grid so that we can try to identify any risks or any issues to the grid as a result of these possibilities in the future. And what I'm going to show here are some final results from what we call our system needs assessment. So what might the system need in the future? And I'm going to focus on 2 areas in particular that are very relevant for offshore grid connections. This document, a summary of it was released in October, and the final version with much more detail and more information will be released next week. So what you see here on the left is Dublin. And the Dublin region is our largest load centre on the island, so a lot of the electricity flows into the Dublin region. We've also got an enormous amount of interest in data centre connections and larger industry connections in Dublin, which is going to drive needs on the system over the next 10, 20 years. So what you can see here on the right-hand side is how we have how the need grows and how the need develops over time from 2025 out to 2040. And we see that in 2025, primarily due to these large energy customers connecting, there is a need to develop the grid, and that will further increase over time to 2030 and 2040 as more offshore connects onto the system also. Looking to the right then, to the southeast region, this is really a part of the grid that is used as a transfer. To the north of it is Dublin, to the south of it is Cork. So it's really used as a funnel to transfer energy from these main load centres on the island. And what we can see here is in 2025, as some offshore wind connects onto the grid, I think in low carbon living we've about 800 megawatts connecting in that time frame, we're starting to see a need develop on the grid. That then progresses over time in 2030 in low carbon living, where we have 3 gigawatts of offshore connected, a lot of which is connected on the east coast. And we also have very high levels of solar PV in this area and further interconnection connecting at multiple points in the island. So all of this is really driving a potential need if this type of scenario were to materialize on the grid. So these are the types of things that we need to begin to plan and begin to prepare for. And over time, as some of the offshore projects become more certain and we've much more information as to where they're precisely going to connect, we'll be able to plan the grid accordingly and progress reinforcement projects or smart network solutions to better optimize the existing grid there. So that's the long-term view of how the network needs to develop. Looking at the shorter term, we've received an enormous amount of interest and inquiries to our access planning team on the East Coast in particular, both from a large energy demand customer point of view for where they can connect in Dublin specifically, and then multiple generators asking us for feasibility studies on what we can accommodate on the East Coast, running from Louth all the way down to Arklow, both conventional generation and offshore generation. So our access planning team have worked on a East Coast generation assessment study, which has now been completed, and the publication is undergoing approval. And what the publication is going to basically determine is the capacity available for offshore wind connections at multiple points along the East Coast, and the capacity available for different types of conventional generation along the East Coast also, particularly looking at existing substations and where there's space available so that the grid is not needed to be able to develop further in order to connect these projects. I've been told that the outcome of the assessment is quite positive, so we're looking forward to sharing more information on that in the coming weeks. So that's some of the network side of things. Maybe just to talk about some of the operational side of things as well. So as I mentioned, we currently operate the system with a largest single in-feed of 500 megawatts. And a lot of our operational practices are set up in order to essentially save the system if we were to lose that connection. So if an interconnector were to trip, for example, we have defined operating reserve products and services that will mean that we won't be in a blackout situation or a customer load shedding situation. However, if we increase this to taking 700 megawatts as an option, based on our current system and how our current thinking is carried out, we would see potential system instability if we were to lose this single connection point. We would see rates of change of frequency from 50 hertz at 1 hertz per second speed, which is in excess of our future operational capability. That would cause a lot of issues on the grid, and we'd very likely to see customer load shedding. So when we carried out this assessment, we then thought, okay, how do we need to progress this, or what solutions do we need to build in order to make sure that this doesn't happen if we do get a connection of this size? So we ran multiple different types of simulations, looking at different types of demand response, more services from different energy storage, looking at power electronic connected devices such as wind or solar or offshore generation to provide us with support to the grid. And what we found was that we need to be able to more smartly operate the system to inertia levels that mean we don't exceed our rate of change of frequency standard, and that we also need a faster reserve type service. So at the moment we've defined a 2-second fast frequency response service that will give us a response up to 2 seconds after an event occurs. We're seeing if we want to go beyond 500 megawatts that we need to basically decrease this time down to 1 second. So you're really talking about new technologies connecting onto the grid to be able to help us manage this type of in-feed. And given what we believe to be the connection timelines, we definitely believe that we can implement this within the time frame of a new largest single in-feed. The next thing I want to talk about is curtailment levels. And to talk about curtailment levels, I'd like to touch on the story so far and how we've managed the system to date. So what you can see here is the installed wind capacity on the system moving from 2011 all the way up to today. And we have doubled the installed wind capacity on the island over that time, more than doubled. And there's been no major increase in curtailment or dispatch down, as we call it. This is as a result of a lot of changes that the industry has brought forward and changes that we've made to how we operate the system. We're very regularly operating the system at up to 65% of our demand being met instantaneously by non-synchronous generation like wind and solar, and our goal is to move that to 50 or 75% by 2020. And it's this type of operation that has resulted in what I'm glad to say is a new all-island wind record last Friday. At about 8 o'clock in the evening, we reached 3,677 megawatts of generation coming from wind on the system at a time when our demand was 5.3 gigawatts. So 70% of our demand was being met by wind generation at that time last Friday. But how do we move forward into the future, and what do we need in order to go beyond our 40% renewable electricity target and to keep curtailment levels at these low levels? We can either accept the curtailment levels as being inevitable, or we can try and do something about them. So what we've started to do in Eirgrid is build a new project which is funded by the Horizon 2020 fund from the EU, and it's looking at going beyond 75% SNSP out to 2030. It's called EU Sysflex, and it aims to achieve 50% renewable electricity on the European system by 2030 and much higher levels on the Ireland and Northern Ireland power system in that time. What we learn from the EU Sysflex project will then form our roadmap for how we develop the grid over the next 10 years into what I'm going to call DS30 and what we need to move on to over the next 10 years. There's other things then that we can do in order to maintain low curtailment levels. We can increase the levels of interconnection, so we've got good progress on the Celtic interconnector and Greenlink interconnector, which will allow us to export this excess renewable electricity. And we can also deploy new technologies on the grid, like battery energy storage, like demand response, to help us give us the services we need at these times of high levels of wind energy. And we're already instigating a lot of that through different elements of DS3. One thing that's very important that a lot of people tend to overlook is that for the last 10 years we've had regulatory alignment and we've had government policy alignment in Ireland and Northern Ireland on what our renewable electricity target is for 2020. If we don't have that alignment for 2030, things are going to be much more difficult. We operate as one island grid, we operate the same system, and we operate to the same standards. If we have very different goals, it's going to make this challenge much more difficult. So that's some of the talking points I just wanted to raise today on how we're turning some of these challenges into solutions through things like the Tomorrow's Energy scenarios, through the East Coast Generation Assessment, and then from an operational perspective, how we can continue the work of DS3 through the EU Sysflex project and ultimately into DS30. Thank you.